Hey people, Algebra 1A kiddos, Mr. Hayward here. One of the last videos that I'm going to make for this school year. Seems weird. We're doing the Chapter 5 review part 2. We did part 1 last week where we did a little bit of graphing. We did solving systems by graphing, solving systems by substitution. Part 2 has the rest of Chapter 5, solving by elimination, and then inequalities. All right, so we're going to start with number 1. We're going to do all the odds today for the rest of part 2, which it has, 16 problems. So we'll do 8 questions today, and then we will do 8 more on Wednesday, and those will be the last videos that I'm going to make. Next week is the end of school, so just you have until then to do all these assignments, turn them in to get the credit. All right, let's look at number 1. Now, this is solving by elimination. This is one of the last things we learned in terms of solving systems. These are both in standard form. They would absolutely suck to graph. Neither of them says y equals or x equals, so substitution sucks too. But we did find out that we could do something that could be helpful. We could add these two equations together, which seemed weird until we talked about the fact that I'm essentially adding 6x plus 6y on the left-hand side, and then I'm adding 6 on the right-hand side, if we're thinking in terms of the top equation. Since those two things are equal, based on this equal sign, I'm treating both sides equally. And we also noticed a negative 6y and a positive 6y, when I add them together, they go away. So now I've got 3x plus 6x, which is 9x. Negative 15 plus 6, which gives me a negative 9, and I'm looking at a one-step equation. When I divide by 9, I get x equals negative 1. Done? Not done. I shouldn't say that. We're done with figuring out x. Then you got to take x and you got to plug it back in somewhere to figure out what y is. I don't care if you use the top equation, bottom equation. I am going to use the top equation. 3x minus 6y equals negative 15. But instead of x, we just figured out what x is. I'm going to plug in negative 1, and then I solve. So 3 times negative 1 is negative 3. So negative 3 minus 6y equals negative 15. That is now a two-step equation. Add 3 to both sides, you get negative 6y equals a negative 12. And when I divide by negative 6, I get y equals a positive 2. Don't forget, take these two pieces, x equals negative 1, y equals positive 2. Go back and write them as a point, and that is your answer. So solving by elimination. All right, let's keep going. Number 3. So for number 3, we're going to look for the same thing. We're going to look for opposites. Like, for instance, in number 1, we had a negative 6y and a positive 6y. So we're going to look for opposites down here. 3x and negative 6x. Not opposites, because that's a 3 and a negative 6. Those won't cancel each other out. Negative 9 and a negative 1. Also not opposites. Shoot. So here's where we had to make opposites. So you had to say, I'm going to multiply one of these equations by something. Now, what I'm going to do is I'm going to multiply this top equation. Let's ignore that. I'm going to multiply it by 2. Here's why. Okay. When I multiply 2 times 3x, it gives me 6x. Now, I also need to multiply 2 by both of these things. So 2 times negative 9y is a negative 18y. And 2 times 27 gives me 54. But notice something. Now I've got a positive 6x. The bottom equation started out with negative 6x. And now I have opposites. Once you have opposites, you add them together. Boom. 6x minus 6x goes away. Negative 18y minus 1y gives me a negative 19y. And on this side, if I take 54 minus 16, that gives me 38. So then I will do my one-step equation, and I get that y equals negative 2. Look at that. So if you don't have opposites, you got to make them. Now that was just the y. I've got to go plug that back in. I can plug it back in here. I could plug it back in here. Or I could even plug it back in here to this red equation, this new one that we made. It doesn't matter. I'm going to look for the one with the smallest numbers. Probably this one right here, negative 6x minus 1y equals a negative 16. Those are the smallest numbers that I see. So now notice this says y equals negative 2. So I have to come back and plug negative 2 in for y. Done. Okay. Now we solve. Let's see. Negative 1 times a negative 2 is a positive 2. So negative 6x plus 2 equals a negative 16. Now we have a two-step equation. I subtract 2. Negative 6x equals negative 18. And when I divide by negative 6, I get that x equals 3. Don't forget, take these two things, write them as a point. 3 comma negative 2. X always comes first, and then y. And we're done. Boom. Okay, number 5. So we're going to look for the same thing. We're going to try and find opposites. Now, do we currently have opposites? Take 2.5 seconds to figure that out. You should say no. So what I'm going to do is I'm going to see what can I multiply by to make opposites. Well, let's see. What can I multiply this right here by to make it into a negative 6x? What if we multiplied this entire bottom equation by 3? Because 3 times 2x is a positive 6x. I'm sorry, I'm trying to make this into a positive 6x because that's the opposite of a negative 6x. So the top equation is not going to change. Negative 6x plus 6y equals negative 7. But the bottom equation, after we multiply everything by 3, I know that these two right here are going to be opposites. But don't forget to multiply everything else. 3 times a negative 2y is negative 6y. 3 times 2 is 6. All right, now we add them together. Now, hopefully you automatically should notice those two go away. But then you should probably also notice these two are opposites as well. So what do I have left on this left-hand side over here? Hopefully you remember that's 0. On the right-hand side, negative 7 and a 6 squished together to make negative 1. 0 equals negative 1. Not true, meaning it is a special case, and our answer is no solution. Done. Don't forget, if your variables drop out and you're left with a false statement, no solution. If you're left with a true statement, then you would say infinite amount of solutions. Just like if we were to graph them, if they were parallel, it'd be no solution. If they lie right on top of each other, it'd be infinite amount of solutions. All right, last one on this page, number 7. All right, so here's where it gets a little trickier. Just got to ignore the fact that that says number 7, so it doesn't confuse you. All right. It's going to be a little bit harder here to figure out what should I multiply by, because I can't just multiply the top equation or just multiply the bottom equation without using like fractions or decimals, and that's going to get tricky. So let me give you a shortcut here. I'm going to multiply both equations. I'm going to multiply them by these numbers, 6 and negative 4. Well, ignore the negative. 6 and 4. Except for, I'm going to switch them. So notice I multiplied the top by 4 and the bottom by 6. Now, I'm just going to do the first two on each of them. 4 times 6x is 24x. On the bottom, 6 times the negative 4x is a negative 24x. Now, we're going to have to multiply the rest of it. But just so you can see right there, 4 times 6 and 6 times 4 are going to give me the same number. And then one's positive, one's negative. All right, let's keep going on the top. 4 times 4y is a 16y. 4 times negative 10 equals a negative 40. 6 times negative 5y is a negative 30y. And 6 times 9 is 54. All right. Now you can see I've got opposites, and I can add these together. 16y and a negative 30y give me a negative 14y. And then 40, and then negative 40 and 54 give me 14. Okay, then when I divide by a negative 14, I get y equals negative 1. Don't forget to take that and plug it back in. Anywhere you want. I'm going to look for the smallest numbers. It's probably here, right? Negative 4x minus 5y equals 9. And then I just figured out that y is equal to negative 1. So instead of y, I'm going to plug in negative 1, and then I'm going to solve. So negative 5 times negative 1 is a positive 5. Two-step equation. Subtract 5. When I divide by 4, I get x equals negative 1 as well. Interesting. Don't forget, go back and write your answer as a point. Negative 1 comma negative 1. That is my answer. So if you're ever stuck and you're looking at trying to solve by elimination and can't figure out what to multiply by, just pick. Like I picked my x's here, and then I took these two numbers and I flipped them. Now you always want to make sure one is negative and one is positive. I already had that. Negative, positive, so I'm good to go. I don't have to mess with that. 4 and 6, multiply. Boom. All right. Now we're moving on to inequalities. So we're going to graph this. Y is less than or equal to 2x minus 1. Very similar to equations with a few differences. Now, similarities, you still would start at your y-intercept of negative 1. Then I would follow my slope, which in this case is up 2, right 1, up 2, right 1, up 2, right 1. Or I could go the other way, down 2, left 1, down 2, left 1. Now here's where the differences start. Don't forget that you're not always going to have a solid line. Sometimes you're going to have a dotted line. So you've got to ask yourself, how do I know? Well, you look at this right here. Is there a line underneath here? If there is that or equal to line, then you're going to have a solid line. I know it's okay to be impressed. I am using a ruler this time as opposed to a popsicle stick. Not a big deal, but it's okay to be impressed. Now, if that had said less than, without the or equal to sign, that is when you would use a dotted line. Now, we're not finished. One more thing. You have to say, do I shade above or below? Well, since this says less than or equal to, the less than part is what we're looking at this time. Shade above, or you shade below. So, just as a short recap, these two signs mean solid. These two signs mean dotted. Okay? These two signs mean shade below because they're less than. And these two signs mean shade above because they're greater than. So here we're looking at, does it have the line underneath or not? And then here we're looking at which way is your inequality sign facing. Less thans mean below, greater thans mean above. Okay. All right, let's look at number 11. A little trickier because this is in standard form. So before I do anything else, I'm going to come with my open space here, and I'm going to change this into slope-intercept form. It's also going to be weird because it's got a 0, but don't freak out. All I need is to get the y by itself. So don't forget that there's a 1 in front of the x. I'm going to subtract 1x. Negative 5y less than or equal to negative 1x plus 0. You don't even need to leave it there, but if you want to, that's fine. Then I divide by negative 5. Y is less than or equal to positive 1/5 x. Again, you could put plus 0 if you want, but really this is the inequality. And the only reason some people like to put plus 0 is because it reminds them that that's where I start graphing. So I'm graphing y less than or equal to 1/5 x. And again, sometimes people like to put plus 0. So 0 means I start in the middle. Okay. 1/5. That means I go up 1, right 5. Or down 1, left 5. Now, I just drew a solid line here. Let's go back and double check. Was that correct? Oh, yep. Less than or equal to. It's got the line underneath. There we go. All right. Now, I want to come back down here. Does anybody see my mistake that I'm just now catching? Think about it for a second. Hopefully this didn't confuse you, but this right here. I divided by a negative. What didn't I do? I didn't flip my sign. Crap. So I need to go back here and remedy that because that makes a huge difference here. That would change how we shade. Now, it wouldn't change dotted or solid. We still are going to have that line underneath no matter what. But because down here I divided by a negative, I should have flipped that sign. Whoops, sorry. So anyways, I'm actually graphing y is greater than or equal to 1/5 x plus 0. And since it says greater than, that means I shade above. And I'm done. Look at that gorgeous shading. Beautiful. The only thing we did after that is systems of inequalities. It'll look like this. Meaning, I'm going to give you 2 inequalities, and you have to graph them and then find the commonly shaded area. So I'm going to graph the top one in black, bottom one in red. It's the worst star I've ever drawn in my life. All right, so top one here. Start at -3. And then I have a slope of -2/1, down to right 1. Or I could go up to left 1, up to left 1, up to left 1, up to left 1. Then dotted or solid. This is a solid line. I'm putting a lot of solid lines here. Then, do I shade above or below? Well, since this is greater than, I shade above, but don't forget, I'm not actually going to shade right now. All I am going to do is put arrows and say, okay, I would shade above. Now the bottom one starts at +1, and I've got a -2/3, meaning I go down 2, 1, 2, 3. Down 2, oh, I'm off the graph. Or instead of down and right, I could go up to left 3, up to left 3. Again, this is a solid line, so I'm going to take these dots I just put down, I'm going to connect them with a solid red line that's looking gorgeous. Then since this says less than, if I were to shade right now, I would shade below. Okay? Then you got to find the place that's commonly shaded. All right, so like this chunk up here, top right, it's got blue arrows, but the red arrows are pointing away from it. This chunk down here, bottom left, has red arrows pointing towards it, see? But the blue arrows are pointing in the opposite direction. You even have this little piece up here that's got nothing pointing to it. Very lonely. But this chunk right here, this oddly shaped, what is that technically called? Quadrilateral? Yeah, there's a math word for you. This shape right here is my commonly shaded area. And that is also the answer to my system of inequalities. Done. All right, then remember, if I were to ask you questions, if I were to say like, is this point A solution to the system? You would say no. If I were to say, this point B right here, is that a solution to the system? You would say yes, so on and so forth. Even if I were to ask this point C right here, is this a solution? You would also say yes, because it is on a solid line, so it's included. All right, let's go for the last one for today. Same thing with the exception that these suckers are in standard form. So we got to do a little bit of pre-work. So I'm going to go down to my empty space, and I'm going to start with 4x plus y is less than -3. Change that in a slope-intercept form. And then I will do x minus y is less than -2. Change that in a slope-intercept form, and then we can graph. This one's nice and easy, one step. If I subtract 4x from both sides, I have not multiplied or divided by a negative this time, so I don't change the sign. Woo! Okay, so then I come up here and I'm just going to rewrite this. Y is less than -4x minus 3. Done. This one, on the other hand, you've got to remember there's ones in front of these. So when I subtract 1x from both sides, I still have a -1y is less than -1x minus 2. And so I'm not done yet because I have to get rid of this negative. So when I divide by a -1, Now you have to say in your brain hole, oh shoot, I've divided by a negative, so I'm going to flip my sign. And I'm even going to remember this time. Y'all proud of me? Woo! Y equals, let's see, negative 1 divided by negative 1 is a positive 1x. Negative 2 divided by negative 1 is a positive 2. And so this is what I'm graphing. Y is greater than 1x plus 2. All right. You know what you're doing? That part can be quick and easy. So I'm going to start at the top here. This top equation, y is less than negative 4x minus 3. I started at minus 3. And then I have a slope of negative 4 over 1. So down 4, right 1. You can quickly see I'm going to run out of room. So instead, I'm going to go up 4, left 1. Up 4, left 1. Now I need to look here and say solid or dotted. And this is the first example I put on here of something that is dotted because it does not have that or equal to line underneath. Then you would ask yourself, do I shade above or below? Since this says less than, if I were to shade right now, I would shade below. But I'm not going to shade right now. I'm going to move on to this red inequality. If I ever accidentally call these equations, I'm sorry. These are not equations. These are inequalities. Okay. This one starts at a positive 2. I have a slope of 1 over 1, so up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 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 1. You can fit a whole bunch of dots. Then you'd look at this and say, this is going to be a dotted line, a bunch of dots, dotted line, because I don't have that or equal to line underneath. I have a weird dot right there. Whoops. Okay. And then if I were to shade above or below, since this is greater than, I would shade above. Now you got to find your commonly shaded area. Hopefully you're getting good at this. You can see it's right here. Okay, then I could ask you a bunch of questions. Like I could call this point A. Let's call this one right here point B. And then let's call this one right here point C. And I could say, of those 3 points, are any of them solutions to the system? Hopefully, A, you could say, not in the commonly shaded area, not a solution. Then hopefully you could say, C, yes, in the commonly shaded area. Oh, my lights went off on me. Now you haven't been in the school building long enough, or in a while, but still have lights on automatic timer. Anyways, so A, yes, or sorry, A, no, C, yes. The question is B, is that part of the system, as a solution to the system? And you should say no, it is not. Weird, right? Because up here we said this one on the line was, but this one's not, and it's because this is a dotted line, okay? This one is on a solid line. Let me give you an even trickier one back up here, actually. I want you to look at the intersection right here. Would this be a solution? Yeah, it would be, because it's on 2 solid lines. What about this intersection? Is that a solution if we called that point D? And you should say no, it's on dotted lines. It has to either be in the shaded area or it has to be on a solid line. It cannot be on a dotted line. That's it. Okay, that is all the odds. We will do the evens on Wednesday. Miss y'all.